Hello everyone, my name is Anna. I'm part of the team here at Define Instruments, and today I'll be taking you through a short presentation to introduce to you one of our latest products, the TwinLink, a point-to-point wireless input-output unit. This presentation will take about half an hour. If you have any questions during the presentation, please enter them at the window on the side of your screen and I will answer them at the end of the session. What you will learn today. The first thing I will be covering is what is the TwinLink and how does it work. And I will also cover how it differs from the traditional mesh networks that operate today that you might be familiar with. I'm also going to cover some of the fantastic features and capabilities of the TwinLink. Then I'm going to hand over to one of our engineers who will show you just how simple and easy it is to set the TwinLink up using our toolbox software. Then we will go on to show you some application examples, and then I'm finally going to end with a question and answer session. Right, let's meet the TwinLink. The TwinLink is designed to be used for transmitting a signal, such as 4 to 20 milliamp, via a wireless link in an industrial environment. The beauty of wireless communication is it eliminates costly cabling to get your signal from one device to another. Wireless communication is also a great time saver, and with Define's simple setup software, you can have these devices talking in no time at all. The most common question we get asked with the TwinLink is, what's the transmit range? It's the transmit range between your TwinLink input and output unit is 0.9 of a mile, line of sight. Now you can extend this to 2.5 miles with the larger 8 dBi antenna. Within buildings, it can transmit through walls up to 1,000 feet. It has two universal isolated analog inputs that can measure 4 to 20 milliamp, temperature, resistance, potentiometer, and frequency. It will also transmit up to 4 digital input signals. Now this means that 4 digital signals on the transmitting unit will be sent to 4 digital outputs on the receiving unit, and vice versa. This is ideal for transmitting digital signals such as pressure switches and alarms. The other great thing about the TwinLink is that anyone who is familiar with 4 to 20 milliamp signals can set up and use these units. They are that easy to use. We call them out of the box ready, and this means that all you have to do is turn the units on. They are already set up for 4 to 20 milliamp in and out, and there is no setup or configuration required. In this diagram, you can see the simplicity of the TwinLink and its advantages over the more complicated mesh network systems. As you can see on the right-hand side, mesh networks are typically used to get data from devices that support Modbus. And to read Modbus data from each device requires a Modbus master, such as a PLC or SCADA system. These Modbus masters have to be programmed by a PLC programmer or a software engineer. The simplicity of our TwinLink is that the inputs are analog, such as 4 to 20 milliamp, RTD, or thermocouple. These inputs are converted to a digital number, and the TwinLink transmits them wirelessly to the receiver unit. This unit then reconverts the signal to a standard 4 to 20 milliamp output. No PLC programming is required, making the use of this unit accessible to a wider range of engineers and technicians. So let's have a look at analog inputs and outputs in a bit more detail. Here is a simple example of a speed sensor and a temperature sensor which has been connected to the input node. The TwinLink input node measures a signal from both these sensors and transmits them to the output node. The output node then converts the signals to 4 to 20 milliamp and drives a PLC input. Let's look more closely at the digital inputs and outputs. The TwinLink can accommodate up to 4 digital inputs. These may be a pulse input or an input from a flow meter or a level switch, for example. They can even be a close contact relay or an output from a PLC. The TwinLink take these inputs, transmit them wirelessly, and output the complete mirror of the inputs. This allows you to remotely control and monitor without the need for cabling. You will notice that the signals can go both ways for the digital outputs and inputs, and this is great for monitoring interlocks or confirming the alarm has reached its destination. Now I'm going to play you a short video showing you a TwinLink application.
A hilltop flower nursery supplier uses water from a reservoir to irrigate its thousands of seedlings. When the reservoir's water level falls below a certain point, the water needs to be pumped back into it from a source at the bottom of the hill. A dense forest is immediately in front of the nursery, and there is no line of sight from the pumping station to the reservoir. To achieve a successful link, 3 devices are required: the TwinLink I/O pair plus a repeater unit. The P2P-I unit measures the 4 to 20 mA output signal from the reservoir level sensor. This signal is converted to a digital message and transmitted to the repeater. The repeater forwards this digital message to the P2P-O unit. It reconstructs a signal into a 4 to 20 mA output that is wired to an existing pump controller. It is also possible to reduce costs by programming the input device as a controller to control the pump directly, removing the need for a separate pump controller.
The reason I chose that video to show you is that it introduced the repeater unit between the input and output nodes. They are designed to enable you to increase the distance between your input and output nodes and to assist in navigating around obstacles to give you line of sight. Here I'm showing you a very similar application to the one I've just shown you. In this application, the input unit is measuring a 4 to 20 milliamp signal from a level sensor in a tank. When the tank reaches a full level, we want the pump to switch off, and when the tank reaches a low level, we want to turn the pump on. This is being done simply and quickly by configuring the set point functions on the input unit. The relays on the output node mirror the set point functions on the input and turn the pump on and off directly. The brilliant thing is that there is no setup in the receiver unit. We will demonstrate how easy this type of setup is when we show you the toolbox software later in the presentation. In this application, a hospital wanted to monitor temperatures in some autoclave ovens. 2 RTD probes were connected to the TwinLink input nodes. The data was then transmitted to the output nodes in another area of the building, where the output nodes converted the signal to standard 4 to 20 milliamp PLC inputs. In this type of application, the TwinLink is specified to transmit up to 1,000 feet through walls and obstructions. Remember that this distance can be increased by using our repeater units. What the customer loved about this application is that they did not need to lay any additional cabling, and commissioning took less than 1 hour. Now I'm going to show you how to configure your TwinLink using our defined toolbox software. One of the nice things about the toolbox is that you do not need to leaf through a long and complicated manual to set up the unit, as we have designed this software to be extremely easy to use. Most of the things are very intuitive in the software, and if you do find things confusing, there is a built-in help panel. This panel updates depending on what you click on, and it will show you the relevant information you need to know right there on the screen when you need it. Now I'm going to show you how to launch the software and connect your TwinLink to your computer. So the first thing we need to do is to launch our toolbox software. Now the next step is for me to connect my TwinLink input unit, which I'm just going to convert to my live webcam to show you how quick and easy it is to connect this up. Here you can see I'm simply powering up the 24 volts into the input unit. I then take my bridge key and insert it into the USB port on my computer. I take the other end of the cable and insert it into the program port on the front of my input unit. And now I'm ready to go. Now I'm going to hand you over to David, who is going to take you through a live demonstration of the toolbox software.
Hi everyone, we're now going to have a look at configuring the TwinLink with the toolbox software. This is the toolbox software. It has a couple of really great features, one of which is the simulator feature here up the top. Here you'll see an orange tab. That actually will let you follow along with what we're doing here today at home without having a TwinLink. So if you haven't got one yet, you can actually click on TwinLink here and you can go through most of what we're doing, or you can just have a play and get familiar with this software at your own time. So feel free to download the software and have a look at that after this presentation. So let's go back to the Connect tab and we'll connect to the unit I've got here on my desk. It's already connected, as Anna showed us, to both USB and power. So all I have to do now is just click the green button and the software goes away and it finds the correct COM port and everything like that from the USB, and it's all connected without you having to worry about anything like that. The diagram in the middle here is showing us our typical setup. So we've got the universal input node in orange. That's what we're connected to now. That's the only thing that we're going to be setting up today. We don't actually have to set up the output node because all of the output node's configuration is programmed into the input node, and then that copies across automatically when you connect things. So it's actually also nice to note that we don't have to have the output node powered today to set up the whole system, so we can set up just the input node, and then later on in the field we can plug the output node into power as well. You'll see on the right hand side of the screen a pane which has got a whole lot of text in it. That is our help information. The information in that pane keeps changing as we click around the software, and it will show you help text that is relevant to whatever item you're working with at that time. So it's a great tool for people who aren't quite so familiar with our products to make their way through the setup. It explains most things in pretty easy terms, and it also gives you example applications and things. So that's a great feature to keep an eye on as we go through this presentation, and you'll see what I mean about it telling you what you need to know when you need to know it. The only other thing we're going to do on this overview page before we start setting up inputs and outputs and things like that is we're just going to have a look at the connected node information down here. Most of this is just status things that we don't need to worry about, but one thing we will have a look at is just to make sure of the regions. So this device is has got several different regions that we can pick from, and you'll see the certifications there. So that's just changing the wireless transmit power to meet the approvals for each country. So we're going to pick USA for this one. We click apply and it goes away and applies that to the unit. So that's all now set up for use in the USA. So we click on the input and output tab up the top here, the purple one, and it's showing us information about our inputs. If you look down the left hand side, you'll see a 1 and a 2. That's our two channels. So I can click on both of those channels and I get data from the two of them. Both channels are interchangeable in terms of features and capability. We're going to use channel 1 today, and we'll be setting that up for our tank application. At the moment it's in 0 to 10 volt mode, and I've got it plugged into a voltage source. So I'll just show you some of the basic features that we've got here, and then we'll have a look at configuring it. Down the bottom, one nice thing to use when you're commissioning or debugging the TwinLink is this live trace graph. So at the moment all you can see there is a blue line. That's actually responding to the input value though. So if I change the input value from 4.9 volts and turn it up a bit, you can see the graph changing as I change the input value. So that's going to give you a real-time idea of what's going on with your signal. So that's quite handy if you've got a noisy sensor, or if you're just debugging something, or you want to make sure that something's there. It also changes and tracks the output as well. So you can see now we're seeing the output from 4 to 20 milliamps, and that's tracking the input as well. Again, we have the help pane on the side, and that's giving us things like our wiring diagrams for our 0 to 10 volt mode. There's a few different options there that we can click from, and it gives us different wiring diagrams. Let's have a look though at setting this up for our example application. So our example application is a pressure sensor monitoring the water level in a tank, and then the other side of the TwinLink pair, the output, is being used to control a motor pump. So the input that we see here, input 1, is that's the signal that we're seeing on the input the input device, input channel 1. The output side is actually on the other side of the wireless link. That's what's coming out of the output node. So when we program in settings here, that's what will come across later on when we power up the output node. So let's put this in to milliamp mode. If I click on the input mode drop down here, there's a whole lot of different sensor types. So there's temperature and pulse and current sensors and all sorts of things. But right here is milliamps, and then we can further down we can select between 0 to 20 milliamps and 4 to 20 milliamps. So we'll select 4 to 20, and that is now going to be set up. If I flick over to my current source and I apply those changes, we can see I've now got 8.3 milliamps going into the device. So that's great if I wanted to know what the value was in milliamps, but I'd prefer it to be in something human readable. So to make it a bit easier for me to understand what's going on, I'm going to go down to our scaling and offset heading here, and I'm going to pick custom scaling. Custom scaling is going to let me show the input value here. I want to show it in feet. So that's feet of water in the tank from 0 to, let's say, 20 is the top of my tank. So if I click edit, I can see here input milliamps of 4 milliamps is a display value at the moment of 4, and input of 20 at the moment is 20. So that's straight, no scaling. But from my data sheet, I know that my sensor at 0 psi will output 4 milliamps, and at 15 psi will output 20 milliamps. So I could put in 0 and 15 here, and I would get the input value coming up in psi, but it'd be better if I can actually put in feet. So 0 psi is going to be 0 feet, and if we look up for water, 15 psi is 34.6 feet. So if I now click done, that 8 milliamps, once I click apply, will be translated into feet. So that's now 10.03 feet of water from the bottom of the tank. The retransmission is still showing for a display value of 4 is a display value, an output value of 4 milliamps. That's actually a bit confusing at the moment because that 4 is now 4 feet, and that's not really going to mean anything to us. So it'd be much better to say that a display value of 0, which is 0 feet of water, is going to be 4 milliamps. And let's say that the top of my tank is 20 feet, so now that's going to be 20 milliamps. So it's nice to note that we don't actually have to put 34.6 feet in here again, so we're using a different scaling for the input and for the output. So if I click apply, you can see that the output value has now changed, and that is scaled now for the extents of our tank being on that 4 to 20 milliamp output. So that's the input taken care of. We could do a few things like filtering and adjusting of offsets, but those are all pretty self-explanatory. And there's also linearization if you wanted to have a funny shaped tank, like a cylinder on its side. But those are all explained in the help here, and you can figure that out. It's not too hard. So let's have a look at the set points for our application. The set points are what we're going to use to control the pump. On the output side, we have 2 relays and 2 digital outputs. At the moment, you'll see that each of these is in transparent mode. Sorry, that one's still in control. But the rest of them by default come in transparent mode. So what the transparent mode does is there's inputs on the input side, and the state of them is sent to the output side, and when they're in transparent mode, they will echo exactly the logical state that you see on the input side. So if you if you close the contact here, you'll close the contact there. So let's have a look at relay 1. We're going to use this to control our pump. It has a whole lot of different modes, but we put them into 2 categories of control and alarm. Because we're controlling a pump, control is the obvious choice. If I select this function drop down here, we can choose from a whole lot of different applications that we've programmed in. You actually see a diagram here as well for the different modes. So we do have heat and cool modes and all sorts of other modes in here, but the one we want today is the energized below, because when the water level goes below our trip point, we want to turn on the pump, and when it goes above a certain value, we want to turn off the pump. So on, off, energized below. And you'll notice that on the right hand side here, our help is showing us a nice graph of the behavior here. So I can set up points here, and that's going to show us how it's going to work. So what we want to do, let's say we want the pump to turn on at when there's 6 feet of water, and we want it to turn off when there is 14 feet of water in the tank. I can now click apply. Alright, and that's all done. That's all ready to go. So that will now, you can see in the diagram here, when the water drops below the value of 6, it'll turn on, and it will turn off again at 14. Okay, that's the toolbox. I hope that was informative. We'll now hand back over to Anna, who will complete the presentation.
Thanks for that, David. Now we're going to cover a few helpful tips that will enable you to get maximum range and signal quality from your TwinLink. When we talk about any substantial distance, line of sight is very important. We get people saying, I can't get a signal, and there's nothing between the units except a hill. That's why we developed the repeater unit, so that you can navigate the signal around obstructions. Height too can be helpful and can improve the signal strength. For example, if you mount the TwinLink at floor level, the signal has more objects to go through, and this compromises the signal strength. By simply mounting the TwinLink at ceiling height, the wireless signal does not have to go through any furniture or machinery to get to its destination, improving your signal strength. Link quality is also very important. While the TwinLink can transmit when the link quality is low, a high signal strength will be much more stable. And for outside installations, remember weather can be a factor. If you have a low signal strength on a fine day, it won't improve in a rainstorm. Now we're going to a Q&A session, and I'm going to invite Anthony, another one of our engineers, to assist me in answering your questions. While we wait for some questions to appear, let's talk about some application examples for the TwinLink. One interesting application that comes to mind is the installation of a TwinLink in outback Australia. Their problem was one of continuous lightning strikes that not only destroyed their instrumentation, but their underground cabling as well. They wanted to monitor both temperature and humidity in various locations on a large outdoor site and send this information back to a PLC. So you can imagine they got very frustrated having to replace their underground cabling every time there was a lightning strike. Our distributor suggested the TwinLink as a possible solution. They installed TwinLinks around their site, linked them to the PLC, and they haven't had to worry about lightning strikes ever since. Oh great, we've got some questions that have come up. My first question is an excellent one. It says, how many repeaters can I use between the input and output nodes? I'll just hand over to Anthony to answer that question.
The answer to the question is you can use 16, but most practical applications you're probably only ever going to use 1 or maybe 2.
Thank you, Anthony, for that answer. That's very helpful. Another question that's come up is, if I mount the TwinLink in a box, is there an extension cable available so I can mount the aerial on the outside of the box?
Yes, there is an extension cable. The first thing to be said is if you've actually got a plastic enclosure, there's no need to actually mount the aerial externally. It's only if you've got a earth, metal, stainless steel enclosure that this will make a difference. So in that application, yes, we do have a couple of cable links that will let you mount the aerial on the outside of your enclosure.
Well, that concludes our session on the TwinLink today. I hope you all feel you are TwinLink experts now after this session, and thank you very much for listening in, and I hope you've found it helpful.